So chapter 3 is all about how we use energy. So we first are going to talk about how we produce energy, where energy comes from, body to move materials within our body, to allow us to breathe, to make larger molecules, to break down smaller molecules. And the main source of energy that our body likes to use is ATP, and we get it through the breakdown of glucose. ATP is adenosine triphosphate. So the definition of energy is the ability to do work. And so anything that allows your body to work is using some form of energy. There are two states that you can find energy in. Potential, which is stored energy. Think of energy in a can of, Powerade, or the energy in the bonds of glucose. Kinetic energy then is the energy of motion. So once you drink that Powerade and you feel more awake and you can do more work, you are changing that energy from potential to kinetic. Kinetic energy is just energy of movement, so the body actually doing something. Anytime we change energy from one state to another, we're going to lose energy. We can convert energy from one state to another state, but when we do that, we lose energy as heat. That's actually the second law of thermodynamics. The first law of thermodynamics is energy can be changed from one form to another. We can't produce energy, but we can convert the energy that is already here from chemical energy to the energy of motion. And then the second law states that if we do this, we are going to lose some energy in the form of heat. So here is kinetic energy of an ion gradient. All of these ions, positively charged, are on one side, very few are on the other side, so they move down their energy gradient from higher to lower energy. Here's another kinetic energy. Electrons moving from one orbital to the next orbital as they're decreasing energy. We can find energy in different forms. So chemical energy is energy that is stored within the chemical bonds of molecules. And so it's not being used at the time, but if we break those bonds, we can release it to do work. Examples of chemical energy, we have chemical energy in proteins, we have chemical energy in triglycerides, we have chemical energy in glucose, which is very commonly broken down to produce ATP. And ATP is chemical energy that our cells use. We also have electrical energy, so this is kinetic energy. This is energy that is associated with the movement of electrical impulses due to electrolyte gradients within neurons and within muscles. We have mechanical energy. This is movement, energy of actual motion. So think of muscle contractions. Think of the body moving. And then we have sound energy. Sound energy is energy of vibrations hitting the tympanic membrane, which is the eardrum, sending signals to the inner ear, even middle then inner ear, so that we can hear different sounds. Radiant energy is energy of different light wavelengths, so different light frequencies that allow us to take in information and produce the vision that we are seeing. So this is just showing where the wavelength energy that we can actually see is right here. There's a lot of wavelengths. We have gamma rays, X-rays, UV rays that we cannot see, infrared rays, and radio waves that we also cannot see. So this is the area that we actually take in and can actually see. And then one form of kinetic energy that is not usable is heat. So anytime we convert energy from one form to another form, so chemical energy to energy of motion would be an example, we release heat as a byproduct. So think about when you get up in the morning and it's, say 2 degrees outside, so it's really cold, right? You're freezing. Your house is only set at, say, 65 because you're saving energy on your heating bill. And you get up and you're cold and you're, shivering a little bit. And you want to get coffee. You also want to put on a sweatshirt to keep yourself warm. But first you have to go to the bathroom. So relieve your bladder so that you feel better. So you do that. You then walk into the kitchen. You get your coffee started. And by the time you have that cup of coffee in your hand, you're no longer cold. Well, one of the reasons is we have converted energy from glucose, which is chemical energy, to the form of energy of motion, which is motor energy, mechanical energy. And as we did so, we lost some energy as heat. That heat helps to warm up our body. So it actually is beneficial in the sense that we're gaining the ability to maintain our body temperature in the cold environment, which is why every time you get really cold, you start to shiver. Your muscles are contracting rapidly to try and release more heat to the body. So I talked about this, but here are the actual definitions for the thermodynamic laws. The first law of thermodynamics states that you cannot create or destroy energy, but you can change energy from one form to another. Do you all know the ultimate source of energy? If not, you should come to class and ask, and we could talk about that. The second law of thermodynamics states that if we change energy from one form to another, we do so with the loss of usable energy. So the amount of energy that we gain from the change of glucose into ATP is less. So glucose has more energy than ATP does, than the amount of ATP we have. But we always lose energy when we convert it from one form to another. And that energy that we lose is in the form of heat. So this is a beautiful figure that I love because it shows the conversion of energy. No matter what type of energy we are converting from chemical to electrical, mechanical, radiant to electrical, sound to mechanical, whatever it is we're doing, we're always losing energy in the form of heat. So what is your metabolism? Metabolism, the definition is the all the chemical reactions that occur in each body cell. That is metabolism. So it has breakdown activities that are called catabolic activities. It has build-up activities called anabolic activities, which we've talked about in the past. So chemical reactions that occur inside of our cells are part of our metabolism. They either build up or break down molecules. And so we can see chemical reactions in different forms. A decomposition reaction, so like a hydrolysis, would be breaking down molecules into their simpler forms. So breaking bonds apart, that's decomposition. Synthesis reaction, such as dehydration synthesis, is a building up reaction, an anabolic reaction, where we're taking two smaller molecules and we're building a bond between them. An exchange reaction is a little different. So an exchange reaction would be a reaction where you have two different molecules that are together. So, in this case, we're saying creatine phosphate and ADP, adenosine diphosphate. And we take a phosphate from the creatine phosphate and we add it to the ADP, and we end up with creatine and ATP, adenosine triphosphate. It's kind of like you go to a dance with one date and you leave with a different date. That would be an example of the exchange reaction. Some more terminology that is really important to understand is the terms oxidation and reduction. So in chemistry, we learned that oxidation means loss of electrons. So you have some atom and you take away electrons from it, it becomes oxidized. Reduction is the gain of electrons. So you have an atom again and you add electrons to it, you have reduced it. A lot of people get confused because if you're adding something, how is it being reduced? But think about what we're adding. We're adding a negative charge. So an electron carries a negative charge. If we add a negative to another atom, we've actually caused the overall charge of that atom to become negative. Because all atoms are neutral unless they enter into chemical reactions. So we take, what do I want to say? Sodium has one electron in an outer orbital. If it gets rid of that one electron, it will have 8 electrons in its outer orbital and it will be happy. All atoms want to have a complete outer orbital. That was in chapter 2, we talked about this. We get rid of that one electron, sodium is oxidized and it has now a positive charge because it now has one more proton than electron. Chlorine then, if it gains one electron, it has an outer orbital that is fully filled. It has 8 electrons in its outer orbital. So it's going to be happy. And if it gains that electron, it now has one more negatively charged electron than positively charged protons. And so it becomes negatively charged. And that is reduced. So oxidation and reduction occur hand in hand, and so we typically call these redox reactions. So here we have a coenzyme called nicotinamide adenine dinucleotide, or NAD, and when it gains electrons, it actually becomes NADH. So I'm going to go back to this slide. In biology, when we oxidize something, we actually decrease, we actually decrease the amount of hydrogen ions that are in the environment. So for oxidation, the term actually means in biology loss or removal of electrons and hydrogen ions. Reduction is the gain of electrons and hydrogen ions. So when we come back here, we see NAD not only gains electrons, but it also gains hydrogen ions. And so NAD is reduced to NADH. and something else is going to be oxidized. I'm going to stop here so you guys can kind of digest what I've talked about, and then we'll get into different exergonic versus endergonic reactions, and then we'll get into aerobic respiration. Bye.